questions 11 through 20 of the 2001 Grade 8 Gauss Math Contest. In a class of 25 students, each student has at most one pet. 3/5 of the students have cats, 20% have dogs, 3 have elephants, and the other students have no pets. How many students have no pets? So they've told you that 3/5 of the students, and the number is 25, have cats. So 3/5 of 25 is 25 divided by 5 is 5. 5 times 3 is 15. And then they tell you that the dogs, there's 20%, so 0.2 of the total, which is 25, and that looks like 5. And then finally they tell you that elephants, 3 of them have elephants, so they just straight give you that number. And they want you to figure out how many have no pets, because the remaining have no pets. So the total is 25. Subtract from that the number of students that have a cat, the number of students that have a dog, and the number of students that have an elephant. So this looks like 2. So 2 students have no pets, and therefore 11, the answer is D. A prime number is called superprime if doubling it and then subtracting 1 results in another prime number. The number of superprimes less than 15 is. So let's write out all the integers from 1 all the way up to 14, because it has to be less than 15. So we've got 1, 2, 3, 4, all the way up till 14, right? So first let's circle the prime numbers, and then we'll worry about superprime. So in this list, 1 is not a prime. Please remember that. Not a prime number. You have no idea how many students get a question like this wrong because they think 1 is a prime. 2 is a prime. 3 is a prime. 5, 7, 11, and 13. All right? So now we have our prime numbers. And so far there's 6 of them. Now, what we need to do is this superprime definition, which is you take a number, you double it, and then you subtract 1. So for 2, you double it, so 2 times 2, and then you subtract 1. And that gives you 3. For 3, you would double the number, and you would subtract 1, so that becomes 6 minus 1, which is 5. And similarly, you do that for all the other ones. So this becomes 9, this becomes 14 minus 1, which is 13. 11 would become 22 minus 1, which is 21. And this would become 25. All right? So I just doubled them and subtracted 1. Now, this new list, how many are prime? This is a prime, that's not. This is a prime, that's not, and that's not. So, the answer is 3. 3 numbers below 15 can be made into superprimes. So the answer to number 12 is B. Laura earns $10 an hour and works 8 hours a day for 10 days. She spends the first 25% of her pay on food and clothing and then pays $350 in rent. How much of her pay does she have left? So $10 an hour, and she works for 8 hours. So that means she has $80. But that's in one day. She works for 10 days. So multiply by 10, you have a total of $800. Then what she does is she spends 25% on food. So 25% of that $800 she spends on food, which is $200. And then she spends $350 on rent. So this was food, and this is rent, $350. and they're saying how much does she have left. Well, the total was 800. Subtract how much she spent on food, subtract how much she spent on rent, and that should give you your final answer, and that is 250. So the answer to number 13 is D. A rectangular sign has dimensions 9 meters by 16 meters, has a square advertisement painted on it. The border around the square is required to be at least 1.5 meters wide. The area of the largest square advertisement that can be painted on the sign is. So we've got a rectangular sign like that, and inside they're going to paint this square. I guess it's going to be some. Oh, yeah, here it is. Square advertisement. All right, so we are going to put a square somewhere in here, like that, or like that. Okay, and then they tell you that the border around the square is required to be at least 1.5 meters wide. So basically what that means is that from here to here, that has to be 1.5, at least 1.5. It can be larger, but if you made that larger, the square would get smaller. So 1.5 would make the square the largest possible, so we'll stick with that. All right, no problem. So that means this is also 1.5 down here. The total dimensions, they tell you, of this big rectangular sign are 16 and 9. So if we've taken 1.5 from the top and bottom, what remains here is, of course, 9 minus 1.5 minus 1.5. And that is 9 minus 3, which is 6. So that means this square has a side length of 6, like that. And they want you to figure out the area. So the area of a square with side length of 6 is 6 times 6, which is 36. So the answer to number 14 would be C. The surface area of a cube is 24 centimeters squared. What is the volume of this cube? So let's quickly draw a cube. So when we want to figure out the surface area basically means that you take the area of all the sides. So this is one side, and you take the area of that, and then you'd keep going. So there's 6 sides or 6 faces to a cube, right? And each face is a square. So each face would have the area of x times x, if x is the length of the square side. So the area of each face is x times x, which is x squared. And the total surface area would be all of those added. So how many faces are there? Well, I already told you 6 faces, right? So the total surface area, total SA, is 6x squared. And that's standard for any cube. And they've told you that 6x squared, they've given you a value, is 24. So we can solve now. X squared becomes 24 divided by 6, which is 4. And therefore x is equal to 2. Now they want you to figure out the volume. The volume of a cube is given by the formula x cubed, length times width times height, but in this case they're all the same. So if x is 2, this becomes 2 cubed, and 2 to the power of 3 is 8. So the answer to number 15 is C. In the diagram, the value of x is. All right, so let's look at this. What do these lines mean? These lines right here. They mean that those sides are equal. So if they're equal, this is an equilateral triangle. And in an equilateral triangle, all the sides are the same, and so are all the angles. So this angle, and this angle are all the same. But we know that all the angles of a triangle are always equal to 180 if you add them up. So from this triangle, I get x plus x plus x is 180, 3x is 180, and therefore x is equal to 60. All right, so this is 60, and this is 60, and so is this one. All right, great. So now this triangle we turn our attention to is isosceles, because you have only two sides that are the same. If there are isosceles triangle, you have these two angles as being the same. So very similarly, if you add up the angles of this new triangle that we're looking at, be y plus 30 is 180, therefore 2y is equal to 150, and therefore y is equal to 75. So this y is 75. Now they want you to figure out x. Well, all the angles about a line are equal to 180. So that means in our diagram that 60 plus 75 plus x is equal to, this x is equal to 180. And if you solve for this, you will get that x is equal to 45. So the answer to number 16 is E. Daniel's age is 1/9 of his father's age. 1 year from now, Daniel's father's age will be 7 times Daniel's age. The difference between their ages is. So Daniel's age is 1/9 his father's age. So that's the first part of the question. 1 year from now, Daniel's father's age will be 7 times Daniel's age. So 1 year from now, his father's age is now f plus 1, and it's 7 times Daniel's age, which is d plus 1, because 1 year from now. So we've got it. We've got two formulas and two variables. We can now solve this. So we'll proceed with this right here. F plus 1 is equal to 7. D is, I can substitute f over 9 plus 1, like that. So this becomes f plus 1 is equal to 7f over 9 plus 7. And we put all the f's on one side, 7f over 9, and this becomes 7 minus 1, which is 6. Get a common denominator. So we got 9f minus 7f, so 2f over 9 is equal to 6. So 2f is going to be 6 times 9, which is 54, and therefore f is equal to 27. And we can substitute f equals 27 back into there, and we'll get d is equal to 27 over 9, so therefore d is equal to 3. So Daniel is 3 years old, his father is 27. And they want the difference in their ages. So the difference would be 27 minus 3, which is 24. And therefore the 17, the answer is A. Two squares are positioned as shown. The smaller square has side length 1 and the larger square has side length 7. The length of AB is. So first let's draw a line from A to B, because that is what they want us to figure out. And I will draw a line from A to this end, and therefore I hope you can see that that becomes a right triangle. And if we can find the dimensions, we can use Pythagoras to figure out the length of AB. So the larger square has size 7, and the smaller square has size 1, like that. So that's 1, 7, 7, all the way around. So that means over here, this length is also 1. I hope you can see that. And therefore this part is going to be 7 minus 1, which is 6, of course. Similarly, if this is 1 here, then this being 7 makes that whole length equal to 8. So I'll put that in, squeeze that in there like this. That whole thing is 8. All right? So this is 6, that's 8. We can now use Pythagoras to figure out AB. So AB squared is equal to 6 squared plus 8 squared. So AB squared is equal to 36 plus 64. This is 100. AB squared is equal to 100. Therefore, AB is equal to the root of 100, which is 10. So number 18, the answer is C. And Beth and Chris have 10 candies to divide amongst themselves. Anne gets at least 3 candies, while Beth and Chris each get at least 2. If Chris gets at most 3, the number of candies that Beth could get is. So we have Anne, we have Beth, and we have Chris. And Anne gets at least 3 candies. So she's greater than or equal to 3 in terms of how many candies she gets. Beth is greater than or equal to 2. And Chris is also greater than or equal to 2. But he gets at most 3. So he's got a boundary there. So for C, it looks like the only possible choices are 2 and 3. For B, we don't know. I mean, it's greater than or equal to 2, but it could be 3, 4, 5, 6. We don't know. And A, similarly, all we know is that it's greater than or equal to 3. All right. The only equation that we have is the fact that they total 10 candies. So that means A plus B plus C is equal to 10. And that's all we have. So we are going to work with the only thing we have with these 2 values of C. So the first scenario is when C equals 2, and the second scenario is when C equals 3. So let's go with the first one. A plus B plus C is equal to 10. A plus B plus 2 is equal to 10. And therefore A plus B is equal to 8. So now we have to look at this and look at our boundaries and look to see what kind of values we can get for B. Well, if A is equal to 3, we start with its lowest end. B will be 5. If A is 4, B will be 4. If A is 5, B will be 3. And if A is 6, B will be 2. And we can't keep going because if we do, B will be less than 2, and we have to maintain that condition. So far we have values of 2, 3, 4, and 5. And that looks like choice E, but let's just complete the question with C equal to 3. So this gives you A plus B plus C is equal to 10. A plus B plus 3 is equal to 10. And therefore A plus B is equal to 7. So now let's do the same thing. When A is 3, this looks like 4. When A is 4, this is 3. When A is 5, this is 2. So the only possible values maintaining these conditions are 2, 3, and 4. So B can be either 2, 3, 4, or 5. So the answer is indeed E for number 19. What number should be placed in the box to make 10 to the power of 4 times 100 to the power of box equal 1000 to the power of 6? So we have 10 to the power of 4 times 100. I'll use an X instead of a box. 1000 to the power of 6. So all of these need to be put into powers of 10. The first one is already in the power of 10. This one is 10 squared, X. And 1000 is 10 cubed to the power of 6. So this becomes 10 to the power of 4 times 10 to the power of 2x is equal to 10 to the power of 18. And then if you're multiplying like this and the bases are the same, you will add the exponents. 4 plus 2x. So remember that. There you go. So now the bases are the same, so therefore the exponents are the same. So that means that 4 plus 2x is equal to 18. Solving for x, you'll get 18 minus 4, which is 14. And therefore x is 14 divided by 2, which is 7. So the answer to number 20 is A.